Structural Steer Challenge. In this challenge, we build a steer structure to the final deliverables that you can expect from a steer detailing software. We started as newbie of Parabuild about 6 weeks ago. We went through the tutorials that comes with the software and had some Q&A with Jet from Parabuild. And 2 weeks ago, we were able to finish a model like this in less than 2 hours based on the project in Malaysia. We used the context modeler during the modeling. To create the joints, we use the joints micro to create them. We use Parabuild default propagation rules to automate the creation of similar connections. We find that Parabuild is the most user-friendly steer detailing software for Autocad. We spent about 5 days during the first weeks to look at how to create joint micros, and we are convinced that we can handle most situations that we may encounter during a project using the software. Tell us what you think, and we will be glad to see how other software perform. We will show you how we create this model step by step, starting with 3D, and if you are game enough, you can download the software and try it yourself. We start by looking at how to create grid lines and level in Parabuild. We use the grid feature to create the grid lines. We can name individual grid lines and the distance along the X and the Y axis. After setting up the distance, we can select OK and the grid will be created. Here is the grid line that we created previously. Next, we will model some levels. This level will be used to help in our structural modeling. We use the modified levels to create the levels for our project. We will name the individual levels and add the individual level with their respective heights. In total, we have created 4 different levels for our project, LV1 to LV4. Using the grid and the levels that we have created, we will make use of them in the modeling of our steer structure. Next, we are going to start adding the columns. We use the context modeler to do this. Before we start, we have to select the profiles. We use the UK Universal Beam. We select the column 2 in the context modeler to model the columns. Next, we select the reference of the column that we want to create. The top at level 3 and the bottom at WCS, which is the 0 level. Let's rotate our view to isometric. Next, we start our column creation by clicking on Draw Framing. We use the cursor to rotate the columns as well as position the columns. Perhaps we can change the graphic representation to view the 3D model pattern. Let's continue to add more columns to our model. Just do a right click to confirm the columns created. Next, we will model the pitch drafter. First, we will turn off the column creation and select the pitch rafter modeling. We will now change the levels of the pitch drafter starting from level 3 to level 4. We also use the snap to ensure that the drafter that we created will snap to the top of the column. Next, we will create the column in the center of the pitch drafter. The bottom is now set to 0 and the top is still at level 4. Lastly, we will unset the reference level and create the columns at the end of the structure. Let's create the beam for our structure. We will use the between column option in the context modeler. And we set the height of the beam. When you are in the space between the column, the system will be able to help you join the columns together. To add the beams at the top of the rafter, we just have to change the levels to LV4. And we do the same to create the beams. For the next sets of beam, we will change the profile to a smaller beam. We select the height of the beams and we use the same method as before to model the beams. We can rotate the beam using the cursor. And we finish off the beam at level 2. For the beams at the back of the structure, these are 1 meter below LV2. Once we set the elevation, we can create the beam. The value of the offset can be adjusted as you model the beams. Let's add more beam, but this time the elevation is at LV1. Next, we will create the beam between the drafter. We will use the option between beams instead of between columns to do this. Now we'll create the beams between the drafter. We can modify the offset from the apex if we want to. We let it snap to the center of the drafter. We are going to draw more beam, this time along the direction of the drafter in between two drafters. This time we are going to draw lines and convert the lines to beams. Let's set our snap before we start. Let's use 2D wireline for better selection. We use the 3D line to create these lines. After creating the first set of lines, we can use the copy command to copy these lines to the other drafter. We can use all the familiar Autocad commands to do this copy. Next, we will select the profile to use. We select our model line, and this will allow us to choose the lines that we have modeled previously. In the profile placement dialog, we can change the profile reference. We will continue the modeling with the addition of bracing to our structure. We select bracing from the macros panel. The software comes with a standard set of macros for bracing which you can add yourself. We select how we want to fix the bracing. For this case, we are going to select the axis of members. We select the two columns and the beam at the top of the bracing to select the bracing. Once we have created the bracing, we can change the details of the bracings, like the profile for the bracing and the various distance. You can see the bracing is represented by the green sphere. Let's do more bracing. We will continue to add more bracing. This time, we are going to fix the top and bottom to the axis of a member. We select the two columns, and this time we have to select the top and bottom beams. For the other bracing on the other side, we will use the propagate to the other side. Propagate is a tool to quickly copy similar micros to other parts of the structure. Next, we are going to create bracing on the roof of the structure. We will use strips for this creation. The macro include the connection macro that we need to add to the ends of our bracing, as well as the connection at the center of the bracing. For this bracing macro, you can see that it consists of 3 macros which you can actually adjust the details. We close the sub macros and we leave with the main macro, which we will propagate settings to the rest of the roof. We need to select at least one beam in the propagation. Next, we show you another way of propagation called the smart copy. We use smart copy to selected parts of the rafter. Now let's continue our modeling with the additional of connections to our steel structure. Parabuild has a lot of connection types. Let's start by using the horns connection. We select the column and the rafter. The system will prompt us with the appropriate connection types available. Let's select the haunch brake. We can adjust the details of this haunch brake using the dialog box. Next, we will use propagate to propagate the haunch brake to the other parts of our steel structure. We continue with the creation of the apex connection. We select the column and the two rafter beam. We will use propagate to propagate this connection. And you can see there are 5 of them in this steel structure. Let's create a connection between the center beam and the rafter. Just as before, we'll select the connection that we want and we will use propagate to propagate to all the various connections in our model. For connections that are slightly different in the properties of the connected parts, we can use Smart Copy to create these connections. Sometimes we might miss one or two connections which we can manually add later. After using Smart Copy, it is time to use Propagate. First, we will select the new joints. Next, we will select Propagate to propagate this selection to the rest of our steel structure. We will now add another connection, which is the beam-to-beam connection. We set up the details and use Propagate to propagate this connection to other parts of the model. At the same time, we can use Smart Copy to copy to some of the situation where the beams are not exactly alike. Using Smart Copy and Propagate, we can complete a lot of connections very quickly. At the same time, there might be connections that are missing because they are slightly different configuration from what we used before. You can create them quite easily using the same procedure. From this example, you can see how quickly we can use Parabuild to build a steel 3D model. Thank you for watching. See you again next time. Bye.